Good morning, everyone. It's a pleasure to be speaking at this first virtual AABC conference. I'm Anne Oxley. I'm a co-founder and executive technical director of Brazilian Nickel. And I'm going to be speaking this morning about how the mining industry can begin to provide the raw materials needed for electric vehicle batteries in the most environmentally sensitive and sustainable way possible. Next slide. Okay, so let's begin by talking about the backdrop. We've seen many graphs like this over the last few years. I've adjusted this one very slightly for 2020 in light of the unprecedented times we've had this year. We know that vehicle sales have reduced drastically, but interestingly, electric vehicle sales not quite as much as traditional vehicles. You know, in the unprecedented lockdowns we've seen this year, I think everybody can understand why that might be, because, you know, certainly in places like London and many other big cities, the air has been cleaner than it's been for decades because of lack of traffic, not because of electrification. But of course, it then gives people a view on what life could be like in 10, 20 years' time if almost all the vehicles on the roads, and certainly in cities, were electric. Now, if we have this type of view on vehicles moving forward, we get to a point sometime in the mid-30s where we get that crossover where there's more than 50% of the world's vehicles sold would actually be electric. And obviously we're going to need an awful lot of raw materials for that scenario. Now there's a small graph there in the corner, which is from Bloomberg a few months ago. I think they're quite bullish about the amount of nickel required. But it's certainly in that region that we're going to need by 2030. So we're going to look today at not just how we can get that nickel, but also how we can get it in the most environmentally sensitive and sustainable way. Okay, this slide gives us a quick snapshot of supply, consumption, and refining capacity. And we can see that the world supply is distributed pretty much worldwide, but with a few key countries with a large proportion of that supply. Indonesia, the Philippines, this is all very much going into MPI. Eventually there will be HPALs in Indonesia, but they're a long way from completion at the moment, and we'll come on to that later. I mean, consumption is a very different group of people than the supply. You know, it's dominated by China. Europe is much larger than its production, as is the USA, you know, and Europe and the USA very much are looking to find materials in a more sustainable, environmentally sensitive way as part of their, you know, as part of their decarbonisation plans. And just briefly there at the end, it just shows the refineries again. They're in the hands of a very small group of people that apply for almost 66% of all refining capacity. Okay, this is a slide we've all seen many times, but it just shows again, you know, basically the nickel that we're going to need over the next 10 years. And that comes down to being something like, you know, 48 projects the size of Brazilian Nickel's Piauí nickel project. You know, people like Tesla, they realize that nickel is their biggest risk from a supply point of view for any of the battery metals that they're going to need. Okay, so why do OEMs care? Well, this is an interesting graph. This is from Volkswagen. It's from their ID production. And it shows here that over 40% of all CO2 emitted comes from the battery production. Now, this is not just the raw materials, it's also the cell production. So there are basically two ways that they can reduce that. Now, the first is, you know, and certainly Volkswagen are looking at doing this with their cell manufacturing in Europe. And they're talking about using only renewable energy. And obviously that will reduce the CO2 emissions hugely. But the only other way they can do that is for the raw materials that they're buying to improve their own CO2 footprint. So let's have a look at how the mining industry can actually try and achieve some of the things that the OEMs would like to see. Now, obviously, any project, any company really these days to fulfill any of this needs to have strong sustainability and ESG credentials. And all projects need to be implemented in as environmentally sensitive way as possible. Low energy intensity is another one. We'll come on to that later with particular respect to heap leaching of nickel. And that applies also to high resource utilization. But what I mean by that is that there is an awful lot of processes out there that have to be very selective about the type of ore that they can take from an ore body. And obviously, if we're limited in our raw material resources. So the more you can take from that particular resource, the more efficient it is, and ultimately better for the environment. I think greenhouse gas emissions speak for themselves, and again, I'll touch on that a bit later in the presentation. Responsible sourcing is very important. We talk a lot about this these days, and therefore how the miner operates, but also how it operates within its own supply chain is very important. Shared benefits, by that we mean, people see miners as often, projects are very profitable, and is that shared with the local communities. A lot of these new projects, I was also, we're in very remote areas, and they can change the area completely, and that has to be done carefully, but it's very important that those benefits are shared with the local communities. And some of that is very simply through taxes and royalties, but others is local employment and making sure that we can train local workforces to be part of the project and part of the system. I mean, transparency is extremely important these days, and there's pretty much being part of the extractive industry's transparency initiative is very important for any mining company these days, irrespective of the jurisdiction they're in. And another one is effective closure planning. Okay, so if we move on to looking at some of those points in more detail, we'll start to look at some of this from our point of view as well. This is our ESG and sustainability approach. While we are a relatively small mining company, just starting in development, this has always been very important to us, and it's something that's key to any funding these days. Our recent funding with the US International Development Finance Corp and our partner TechMet would never have happened if we didn't have good ESG and sustainability policies in place. So basically we have a charter, and the whole aim of our charter is to provide long-term benefits through continuous improvements in health, safety and environmental performance, and sharing these benefits with the communities within which we operate. And we will achieve this. It's very important that we target zero harm. We want to leave a positive legacy in the community. We want to conserve and where possible even enhance the natural environment. We respect and protect the rights of employees and host communities. And we have to absolutely do all business responsibly and transparently. And this then goes down into further detail with lots of policies and procedures that follow on from those, all the operational codes and detailed financial policies and procedures, which lead into the whole transparency of everything that we do. On to the next slide. If we look here in a little bit more detail of really, what heap leaching means for sustainability, I think it's very important. We are heap leaching. We're not high pressure acid leaching, which is where a lot of nickel laterite companies are looking to try and produce metal for the battery market. Now, heap leaching it's much more simple. It's a flexible process. It's all at ambient conditions. There's no high pressures, no high temperatures, and it pretty much uses standard equipment. So this allows us to use a high proportion of any local workforce. Now, where we are in Piauí, it's a remote part of Brazil, and it's a very poor part of Brazil. It's the poorest state in Brazil, and it's very important to us and to the local community and to the state and federal governments that we actually do attempt to use a huge amount of local workforce. I think we'll be up to, in our full-scale projects, well over 65% will be local people that work and everything, and then we move out to the state wide, and then finally countrywide for some of the key positions where we just can't find the qualified people. But the simple process also hugely reduces energy intensity. And again, we come back to resource utilization. There is less mine waste, there's a much longer operational life. And heap leaching, it uses all the ore above a simple economic cutoff. So we don't need to blend, we don't need to separate ore types for the process. It leaches the whole ore body. Another key ingredient from the heap leaching point of view is that we will have, it is a sulfuric acid leach, so we will have our own sulfuric acid plant on site, and that this produces a lot of steam, which we then co-generate power from, which of course is carbon free. And the whole area of Piauí, there is a huge amount of renewable energy, and so our sort of off-site energy and camps and locally for everyone is also carbon free. And we said before that the local community engagement is very important to us. So not just having local people work for us, but also to increase the standard of living for those people who are not working for us. So, you know, so therefore improve education, improve health for the whole communities. And this, of course, feeds back to us because we get very good community support. And legacy is very important. You know, all mines are finite, so they have to close. But ultimately, you know, these days, rather than just rehabilitate and put it back to what it was, particularly in a place like Piauí, where basically the land is very scrubby and really not much use for anything other than almost subsistence farming. So, you know, a closure plan with the local communities is very important to give a lasting positive legacy that they can continue to operate commercially in the area long after the mine is complete. If we move on to the next slide, let's have a look at the environmental sensitivity. And again, we're talking about the heap leaching here at Piauí. I've already mentioned, but you know, not just from a sustainability point of view, environmentally, it's very important that we get the power for the whole operation from our co-generated power from the acid plant. You know, to look at in a bit more detail here at the reduction in energy intensity, you know, I mean, the high pressure acid leaches which are being built in Indonesia, if they had a sulfuric acid plant on site as well, and they don't all, some are using imported acid, but any HPAL that has an acid plant and HPAL producing the same amount of nickel to the production plant at Piauí would basically require an additional 15 to 20 kilowatts of power, and we can actually sell 12 to 15 kilowatts back to the grid. So again, there's just not using those high pressures and high temperatures, you know, reduces the energy intensity hugely. We also have an optimized process. We've been optimizing it for many years now, which basically minimizes water use, which is also very important for environmentally. And our acid consumption is absolutely the lowest it can be through the optimized heap leach process. Now, something that is extremely important at the moment, you know, is residues. And, you know, particularly in Brazil, there've been two major disasters of tailings dams, with including loss of life. And so any operation that can avoid having a tailings dam these days is obviously the best way to move forward. Now, with the heap leaching, you can see there the impurity filter cake. It's a very dry residue. I mean, we do filter it, and we filter it for two reasons, actually. We filter it because we do get dry residues, but we also filter it to reduce any nickel losses. So it's something that's an inherent part of our process. You know, we're not doing this just so we don't have dry residues. We actually need to do it so that we get the best, the most efficient nickel recovery that we can. You know, and I mentioned deep sea disposal there. I mean, obviously we're in the middle of the country in our project in Brazil. We would never, you know, we couldn't do that even if we wanted to, which we don't. But, you know, the Indonesian HPALs, some of them are still looking at this as a possible disposal route for their waste. Two projects I know now have said no, they're not going to do that. So then they need to look at whether they build tailings dams or whether they build huge parks of filters to get some dry residues. But deep sea disposal is obviously is not the way forward for something that's trying to be environmentally friendly to go into an electric vehicle battery. Obviously, the lower carbon footprint, we have a low carbon footprint compared to most nickel production, and we have optimizations possible. Now, I'll move on to that in a future slide. And I think it's quite important as well, the product that you produce. You know, we have got quite long logistic routes. We're 700 kilometers from the coast with good infrastructure. So it's not a problem that we are that far from the coast. But, you know, obviously you want the amount you transport to be as small as possible. And by having the right fit for purpose product, we have, it's a purified MHP, we call it nickel hydroxide product. So it's better than an MHP, and it's around the 50% nickel mark, which is, you know, much better for transport to the customer. Okay, so let's talk about greenhouse gas emissions. These are already inherently low for a heap leach process, but BRN's taking this very seriously. How can we further reduce our carbon footprint? You know, if we can produce carbon neutral nickel or even carbon negative nickel, then obviously that's not only a huge selling point for us as a product going into the electric vehicle market, but it's also, you know, ultimately we're trying for decarbonisation here. So if the raw materials can be carbon neutral, obviously that's the best path forward. Now we have internal LCAs, but as part of our project development as we go forward, we're going to be looking at much more detailed LCAs, which will give us, you know, all the areas where we can try and reduce our carbon footprint. Our current situation has a much lower CO2 emissions than most other nickel production, you know, which includes HPALs and includes the traditional pyro smelting of both sulfides and laterites. Now we're also working on innovations, and again now we're funded. These will be going ahead in earnest in 2021, and to lower or remove any CO2 emissions. Now, in our downstream process, the first stage of treating our leach solutions is to remove the impurities, and we do that with limestone. So obviously we give off CO2. But that's very easy to capture, and it's pure CO2. So basically we're looking at various ways that we can then safely store that CO2 in perpetuity. You know, and one of the solutions we have at the end of our process is high in magnesium sulfate. And definitely theoretically, we could use our own solutions to capture that CO2. Now we've started working with various universities looking at this. And here I'm very much open for anybody else. I think this is something very much that mining companies should be sharing and not trying to treat as their own IP. So, you know, if anybody's working on this and has advances in this, particularly whether it's in the academic field or if it's somebody else, very happy that you contact us and see if there's, you know, if we can do anything together on this one. There's also a lot of work going on, mostly in Canada, out of British Columbia, looking at carbon sequestration, basically in the natural rock that falls with nickel deposits. Now in Colombia, they're looking at nickel sulfides, but again, we have serpentinites that are our bedrock as the nickel laterites, and these naturally sequester carbon. So other ways to improve this process, we'll be looking at that. And a lot of our final waste products, because we also do remove magnesium from the end of the process, sort of semi-alkaline waste, which can also sequester carbon. So we're looking at all sorts of routes for that, some bacterial routes. So there's a lot of work going on there where we feel that we could reduce our CO2 emissions even further. And the results of this, you know, should be available within 12 months as we do our bankable feasibility study. And obviously there are more traditional routes that we can also look at, you know. I mean, we will look at electrification of our transport fleet, whether it be for moving, you know, the buses taking our workforce to the site, or the mining equipment and the equipment basically moving any ore or any waste around the plant. And while we have all our power from the sulfuric acid plant, of course there are times when that will be down for maintenance, and we will need to use the grid. Now the grid locally is renewable energies, but I think we would also look at our own renewable energies. This will be something we'll look at as part of the bankable feasibility study, putting our own wind turbines or certainly solar panels on site and having electric storage capacity, so that we can, if we ever need backup power, we can use that instead of having to use diesel generators. So these next few slides are a bit more general information about our project and the status we're at the moment. So the map there on the right, you can see where Piauí is. It's one of the lesser known states of Brazil. It does have a very small coastline, but it's mostly land. It's mostly inland. It's about our project's about between 650 and 800 kilometers to a choice of 3 or 4 different ports. And the infrastructure is actually exceptionally good for such a remote area. We have a tarmac road right up to 10 kilometers from the deposit. The photo at the bottom there basically shows you the type of landscape we're in. We're not in Amazonia. We're in what we call Caatinga, which is basically a thorny, scrubby forest. So a very little commercial value, and there's no farming around there. There's sort of a few sort of goats and cattle in small farmsteads, but nothing, no major agriculture in the area. I think the key thing to say about the Piauí project is it's an advanced stage project. The key risks have been identified and well understood. We're about to do the final stage of our bankable feasibility study, and we have a highly experienced management team with proven track records. There's a few numbers there. We don't really need to go in much detail on those, but these are from our PFS, but they show very robust economics. We move to the next slide. So this is our demonstration plant. You can see there in that photograph. I think some just key points on where we are at or status just at the end of last month. So we're in the very final stages of completing a funding package. It's taken us a while to get this funding package in place. Unfortunately, it hasn't been affected by C-19. And it's very important for us, this stage of financing, and our financing has come from the United States International Development Finance Corps, which we see as being a game changer for us as a company. They have very strict ESG and environmental regulations and transparency that we have to pass through. And this funding has come through TechMet, who are our funding partner, from the DFC, which is for $25 million US, all of which has to go into Brazilian nickel. We then have a further 2 million equity, which is already agreed. And then finally, to complete the package that we need to do everything we are looking to do over the next 12 to 18 months, we have 15 million of debt prepayment facility lined up with a trading house. So this use of funds, we are going to turn that demonstration plant that you can see there into an early production. I'll go into a little bit more detail on that in the next slide. We will complete our bankable feasibility study for the full-scale project, and that will be done in 2021. And just a few other key points which are just in that right-hand lower corner there. We are an advanced, very low-cost project, which is very important. Low cost both operating and capital. We do have very robust economics, and our pricing is very conservative. We're using $7 per pound nickel, which is actually lower than today's spot. There are very compelling prevailing nickel supply demand fundamentals, not just for electric vehicles, although that could be, of course, potentially transformational on the nickel and cobalt demand. but also from traditional markets such as stainless steel. You know, I mean, this is already drilled to measured, you know, so there's 76,000 meters of drilling already been done, you know, which gives us 72 million tons of 1% nickel and 0.05% cobalt. And our environmental permits have already been awarded for the full-scale project, you know, which means as soon as we finish the bankable feasibility and funded construction, we're ready to go. So just go quickly back to the PMP 1000. This is basically a fast track to producer status. So it takes that demonstration plant that we already have, it converts it into a small production unit. So that will give us around just 14,000 tons per annum of nickel and 35 tons per annum of cobalt. But it uses all our existing mining rights and licenses. And the cost to do this is around 23 million. Now we're doing this because we believe it has huge benefits. It helps us develop our customer portfolio. It will actually provide cash flow while we're still waiting for the full-scale production to begin. You know, and I think this is very key. We are a junior mining company, and it takes a long time to get to production for most companies. And this is a profitable project. You know, it will give us decent cash flow and allow us to not have to keep going back to the markets for funding until we're in full-scale production. But it also enhances our industrial partnership opportunities, which is particularly important in the electric vehicle arena. You know, there are a lot of people now starting to look at where they can find their nickel that they need and the cobalt for the batteries. And, you know, having PMP 1000 means they can actually see us produce in an environmentally sensitive way and have products to give them and have them test to see how they fit into their own supply chains. And we've mentioned a lot, you know, the benefits and the sharing of the community. And so having this allows us to develop our workforce locally and continue to train so that we have a good workforce available locally when we start the full-scale project. So the schedule on this is we kick off construction in January. We expect mining to begin in May. The plant construction will be complete by November next year, and we will actually have first nickel products sold in March 2022. So if we now take a look basically at the full schedule for what we're doing and what we've done since we acquired the project in 2014. We bought this project from Vale. We did our first rounds of funding, so that enabled us to reconfigure their pilot plant into the demonstration plant that you've seen on some of the earlier slides. We then continued in 2017, 2018, raising funds for the project development and to continue to operate the demo plant. A major investment was at the end of 2017 when we did the royalty deal with Anglo Pacific Group, which has 70 million lined up for the full-scale mine construction. And then in end of 2019 and beginning of this year, we received final approvals for all our environmental licenses. And as I've just said before, we are in the final legal stages of completing our 42 million private raise to fund the onward development of the project. So the plan is that in sort of end November, early December, we start the final phase of the BFS. I say the final phase because we have all the technical work completed from the demonstration plant. So all the results from that will feed into the engineering. And we've already done all our METSIM modeling. So it's just the engineering of our process design, which we will begin in December. We expect to publish that BFS towards the end of 2021. And then obviously we would then complete our financing and would expect an IPO to take place as part of that financing. And we would start construction in 2022 and see therefore the beginning of full-scale production in Q1 2023 with full ramp up 12 months later. I think that's quite important. The heap leach ramp up is a lot shorter than a HPAL ramp up, which are typically 2 to 4 years just to reach 8% of nameplate capacity. And I think you can see underneath there, the PMP 1000, we expect to we start construction at the beginning of next year. A year later, we will have our first product from that. And we will basically operate that small production unit until we start the full scale production. And at that point, we would decommission the PMP 1000 project. So we're hoping the future's bright, and it's really great to finally be kicking everything off literally this month. It's taken a while for us to fund. A lot of my previous presentations have been about the need for funding for companies like ours. You know, and we're very pleased with the outcome of the funding and from the investors that we now have. Short disclaimer there for anybody to read later. And basically just, yeah, thank you very much. And as we say, nickel and cobalt made easy by Brazilian nickel. Thank you and goodbye.